So what I would like to talk about today is how we can use the exponential form of roots to simplify something that looks really nasty, like this one. Cube root of x times square root of x divided by the fifth root of x. Now, I would argue that what makes this question particularly difficult is that all of these roots have different indices. Cube root has an index of 3, fifth root has an index of 5, and square root has a hidden index of 2. Now, anytime I'm in the case where I have different indices, I try to rewrite these so that all of them are in exponential form. So help me out. If you were going to rewrite the third root of x as x to some power, what power would it be? What about square root? What about fifth root? Remember that this can be rewritten as cube root 1/3, square root an exponent of 1/2, fifth root an exponent of 1/5. Rational exponents. Now, this is still fairly complicated, but at least I'm in the position now where I can use some of the exponent rules to help me to clean this up a little bit. For example, here's a nice thought bubble here to the side. I could use the exponent rule that says, if you've got two things, same base, multiplied together, you can combine that by adding the exponents. And if you've got two things with the same base divided by each other, you can clean that up by subtracting the exponents. So let's apply those rules here. Working in the numerator, I could combine x to the power 1/3 times x to the power 1/2 by adding those exponents together. I'm going to try and write this really carefully. 1/3 plus 1/2. I could add those exponents together, bringing me to what I believe is x to the power 5/6. 5/6 being 1/3 plus 1/2. So now I'm in the position of x to a power divided by x to a power. And the exponent rules say that you can combine that by subtracting the two powers. 5/6 take away 1/5. And I think that 5/6 minus 1/5 becomes 19/30. That's just some fraction arithmetic there. 5/6 take away 1/5. 19/30. So I have managed to condense and combine this all the way into an expression that has a single exponent and a single base. Much, much simpler than what we had before. So this is my recommendation. Anytime you're simplifying something where your roots have different indices and you're multiplying and dividing them, convert them to exponential form so that you can use the exponent rules.